The quadratic formula can be used to solve any second degree equation, so you can use this if it's unfactorable. You could use it for a factorable equation, and if you don't like completing the square, you could use this as well. It comes from the standard form ax squared plus bx plus c equals 0. And the formula is x equals negative b plus minus the square root b squared minus 4ac all divided by 2a. So we're going to use the quadratic formula to solve negative x squared plus 5x equals 3. Now you'll notice that this is not in standard form because it is not set equal to 0, so we must do that ourselves. Subtract the 3 to the left side. Negative x squared plus 5x minus 3 equals 0. List out your a, b, and c. Negative 1, b is 5, c is negative 3. Plug it into your formula. X equals negative b plus minus square root of b squared minus 4ac all over 2a. X equals negative 5 plus or minus 5 squared minus 4 times negative 1 times negative 3 all over 2 times negative 1. X is negative 5 plus or minus square root of 5 squared is 25. Negative 4 times negative 1 is positive 4. 4 times negative 3 is negative 12. All over 2 times negative 1 is negative 2. Negative 5 plus or minus the square root. 25 minus 12 is 13 over negative 2. You cannot take the square root of 13. You cannot break down the square root of 13. So this is your answer if they want it exact, or you could use a calculator and round it to a given decimal place if they ask. Stemming from the quadratic formula is the discriminant, and it's b squared minus 4ac, which you see inside the square root in the quadratic formula. And b squared minus 4ac allows us to know how many solutions the quadratic will have. Not what they are, but how many there are. So if b squared minus 4ac is greater than 0, so that means it's positive. Positive number in the square root gives you 2 solutions. And graphically, it could be opening up. It will hit the x-axis twice. If it equals 0, there's only one solution, and that means the vertex is the only point that's intersecting the x-axis. If it's less than 0, so negative, that would put square root of a negative number. We know that's an imaginary number. So there's no real solutions. Let's use the discriminant to determine the number of solutions the graph will have. We have x squared minus 3x minus 2 equals 0. It's already in standard form. Now let's list out our a, b, and c. A is 1, b is negative 3, c is negative 2. Plug them in to our formula. B squared minus 4ac becomes negative 3 squared minus 4 times 1 times negative 2. Negative 3 squared is 9, minus 4 times 1 is 4, times negative 2 is negative 8. Minus negative is plus positive, and it goes to 17. Now 17 isn't the answer, it's just a positive number. And we know from the previous chart that when it's positive, there are 2 solutions. So 2 solutions is our answer, not 17. There's 2 more problems on this page that you can try out on your own. We are now going to solve equations with fractional expressions. Okay, we need to make sure to get the common denominator for all parts. Okay. So we have 1 minus 8 over x minus 5 equals 3 over x. So we need to get the common denominator, the LCD. This x has a minus 5. They're together. They are not separate. This has a 1. Our LCD, it's going to be x from the right side, 3 over x, times x minus 5. We are going to multiply both sides by the common denominator. Now when I do this, you put parentheses around this because they both need to get multiplied by x times x minus 5. Okay. We have x times x minus 5 times 1. Distribute the x, that goes to x squared minus 5x, and times 1 doesn't do anything. Next term, we multiply it to the negative 8, just take the negative with it, over x minus 5. Okay. We learned in the previous lesson if there's a common factor, it can cancel. So this goes to just x times negative 8, which is negative 8x. On the right side, 3 over x times x minus 5. The x's cancel. It becomes 3 times x minus 5 equals 3x minus 15. So right now we have x squared minus 5x minus 8x equals 3x minus 5. The highest degree is 2. So that makes it a quadratic. So we need to set equal to 0. So we like to keep the x squared positive. Don't move the x squared side, move the other side. So we're going to take 3x to the left by subtracting it, and we're going to add 5 to the left. So we are now, and we're going to combine all like terms. X squared minus, we got negative 5 minus 8 minus 3, so that goes to negative 16x plus 5. Oh, we did not distribute the 3 to the 5, so that should be a 15. There we go, that works. Equals 0. We are now in standard form, and we need to solve. And on this one, we're going to solve by factoring. What multiplies to 15? That adds to negative 16. So it would be a negative 1 and a negative 15. X minus 1 and x minus 15. Equals 0. And we learn to set both equal to 0. And we get x equals 1 and 15. Our next problem is x equals negative 1 plus root 7x plus 15. Now we see that we have two x's. Here on the left, here on the right. One's inside a radical. One's outside. So we need to isolate the radical first. So that means it's a negative 1. Let's add it to both sides. So we are at x plus 1 equals root 7x plus 15. Now to get it out of the root, we're going to have to square it. What we do to one side, we must do to the other. So put it x plus 1 in parentheses and square it. So we are squaring both sides. So the left side will go to x squared plus 2x plus 1. Right side will become 7x plus 15. We see it's a quadratic because it's degree 2. We must get it in standard form. So subtract the 7x, subtract the 15. So we get x squared minus 5x minus 14 equals 0. We now need to solve, and this one we can solve by factoring. So it goes to x minus 7 and x plus 2 equals 0. Set both equal to 0. And we get x equals 7 or negative 2. Now whenever there's a problem with the square root where you end up squaring both sides, you have to check for extraneous solutions, solutions that do not satisfy the original problem. So let's go back up and check 7 and -2 into their original. I'm going to go to the upper left corner. When x is 7, we get 7 equals -1 plus root 49 plus 15. That goes to 64. Square root of 64 is 8. 8 plus a -1 is 7. So 7 works. Go over to the upper right to check x equals 2. So we get 2 equals -1 plus root 14 plus 15. 14 plus 15, that's 29. And there is no square root of, oh, that's a -2. Okay. -2, -14. So -2 equals -1 plus root 1. Root 1 is 1. So did this work? -1 plus 1 does not equal -2. So we checked. 7 worked. -2 did not. So x equals 7.